Welcome to Ask and Learn.
This is the answer to Chapter 21, problem number 22 from the Smith Organic Chemistry textbook. And this problem asks us to look at two alkanes and synthesize each of them two different ways. In a single step using a Wittig reagent, but also as a two-step process making use of an organometallic reagent. And so for each of these, we're going to have a Wittig method and a Grignard method. And so for A here, so in a single step, A can come from the corresponding ketone. So ketone here instead of the alkane. And if we were to treat this ketone with just a methyl Wittig, so I don't know that you would call that a methyl Wittig. So a single carbon Wittig is what I'm trying to say. So PH3P double bond CH2. So just using that right there, that's going to get us to our desired product. Okay. And so the other way that we could do this, again, we would start from the same ketone. So the exact same starting material. And then, as I said, this two-step method is going to involve using a Grignard. So again, we're just trying to add a single carbon. So this time it is going to be a methyl Grignard. So CH3 MgBr, methyl Grignard. And then, of course, the workup for that is water or acid. And so what that's going to give us is this, where we have the alcohol as sort of the residue of the ketone. And we've also added our methyl group. And so the second step here is going to be to treat that intermediate with some strong acid, some concentrated sulfuric acid, and that's going to give us our desired product. However, we're also going to get some other products, right? And so, in fact, our desired product is probably going to be the minor product. And the major product here is probably going to be this product, because this product is tetrasubstituted, and so that's the more stable double bond as opposed to just disubstituted in our desired. So our desired product is disubstituted. What I've labeled as the major product here is tetrasubstituted, and tetrasubstituted is obviously more stable and therefore is going to form in the greater amount, and that's why it's the major product. And then we also might see some of this. So this tri-substituted product, and of course we can get both the E and Z isomers here. And so one takeaway from this problem is that in an instance like this, using a Wittig reagent obviously is much cleaner. You get a single product, you get the desired product, whereas doing this with a Grignard and then strong acid, you get a mixture of several products, and our desired product isn't even the major product. And so, so that's a key takeaway here is the utility of the Wittig reaction. And so, again, for B, it's going to just be more of the same. So B can come from just pentanone, cyclopentanone. So this starting material, and then again, we can just treat this with the Wittig of what we want to add. So in this case, it's going to be C6H5, so a benzyl Wittig. So pH3P, double bond, CH, C6H5. And that's going to give us our desired product. It's a terrible 5-membered ring I started to draw. Right. And so CH, C6H5. And then so like in part A, we could also do this from the same starting material. And actually, rather than try to cram this all in on one page, I am just going to move to a second page here. Okay, so that's plenty of room. And so again, as I said, we could start from the same cyclopentanone starting material and treat that with the Grignard version of what we want to add. So it would be a benzyl Grignard type reagent. So C6H5, CH2MgBr. Right, so there we go. And then again, the workup for this is going to be water or some acid. So we'll just use water. And that's going to get us to here. So again, we'll have, just like in part A, we'll have the alcohol as sort of the residue of the ketone, and then we will have added our desired group here, so CH2, C6, H5. So we've added our benzyl group. And then again, just like part A, once again, treatment with some consulfuric acid. So H2SO4 is going to dehydrate this system and get us to our alkene. C6H5. But again, like part A, what we're going to see is that there's a possible side product as well. So so this is tri-substituted, but our potential side product is also tri-substituted. So our potential side product is going to look like this. Obviously, depending on which hydrogen. So here. So when we treat this with consulfuric acid, we're going to protonate the alcohol. The alcohol will then be H2O and want to leave. And so for our main product to form our desired product, one of these hydrogens will go as well. And for our side product to form, a hydrogen on this carbon could potentially also leave. And so that's going to determine which we get. So in our desired product, because of the aromatic ring, this C6H5, our desired product is conjugated. So it's probably much more likely to form. But we will see some of this also tri-substituted side product as well. So again, this problem is really driving home the point that a Wittig reagent is much more useful in selectively forming these types of products as opposed to a Grignard reagent. Yeah, and so that's the answer to chapter 21, problem number 22.